Hello everyone. In today's video we are going to discuss about how to implement a queue of integers using a single linked list. In the previous video we have discussed about how to implement a stack using a single linked list. As we know that in case of a stack, insertion and deletion operation, that is the push and pop operation, are done using the same end. But whereas in case of a queue it differs. Insertion is basically done using the rear end and the deletion is done using the front end. So in case if I want to implement a queue using a single linked list, note that to build my or to implement my enqueue operation, enqueue means this is the insertion operation. Insertion in case of a queue is done at the rear end. So to implement my enqueue operation, I am supposed to go for insert end function that we have discussed in the previous videos while discussing the insertion and the deletion function with respect to single linked list. So if enqueue operation is done at insert end, note that my dequeue operation should be done at the delete begin. Now if I perform insert end and delete end, then it becomes a stack. In case while implementing a queue, note that insertion is always done using the rear end. So therefore I am supposed to use the insert end function. In case of the deletion, with respect to a queue, I know that deletion is basically done at the front end. So my deletion function should be written with the help of delete begin function. So keeping in this mind, now we'll come up with the header file. So the same things include stdio.h and stdlib.h. Write a macro for the size of your queue as 5. Declare a global variable by name count, so that whenever you are performing an enqueue operation, you are incrementing count, and whenever you are performing a dequeue operation, you are decrementing the value of count. Now write the structure definition to represent a node. Struct node int data. Why int data? I am implementing a queue of integers. So int data. Second argument is struct node. Use a type def statement. Type def struct node star as capital node. This is about the structure definition and the header files to be included for the program. Now coming to the enqueue function. Function name enqueue, to which two arguments. One is the reference of my list, that is node start. Second one is the item to be inserted onto the queue. Return type of the function as node. Note that here to come up with an enqueue function, I am supposed to insert a node at the end of my list. Node. Declare two variables, one as current and one more as temp. Now before allocating memory for the new node temp, first check if count is greater than or equal to size. Printf queue is full. Return start. If queue is not full, then allocate memory for temp. Temp is equal to node malloc size of struct node. Temp of data is equal to item. Temp of address is equal to null, because your temp will be the last node. I am supposed to insert a new node at the end of my list. Now current is equal to start, while current of address not equal to null. Only one statement, as so I have not opened while. Current is equal to current of address. Now current will be holding the address of the last node. Make current of address pointing to 10. Now update your count. Count is equal to count plus 1 and return the address of the first node. Return start. Yeah, this is about enqueue function. What we are doing? Just we are going to end of the list and we are inserting a new node at the end of the list. Now quickly coming to the dequeue function. Now deletion is done using front end. Just write dequeue, argument to dequeue function is the reference of my list, node start, return type of dequeue is the address. So if list is not there, then nothing is there in the queue. So if start is equal to null, printf, queue is empty. Return null. If not, make temp to hold the address of the first node. Temp is equal to start. Change the reference of start from first node to second node. Start is equal to start of address. I need to declare temp. Printf node deleted is %d, which is nothing but temp of data free temp, decrement the value of count and then return the address of the second node, which is nothing but start. This is about the dequeue function. This is almost nothing but okay. We are rewriting the same deletion from the beginning of the list. Now coming to the display function. Or rather than writing list as empty, I am just writing it as queue is empty. Else printf queue content or initialize the temp to the starting of your list, traverse the temp while temp not equal to null, printf %d, tab space temp of data, temp is equal to temp of address. Close your while, close your else, and close your function. This should be fine. This is about the display function. Coming to the main function. Now if you see in case of the main function, there is the variable start which is being initialized to null and there are two other integer variables by name item. That is the item to be pushed onto, the item to be inserted onto the queue, and one more integer variable to take the decision what needs to be done, whether I am opting for Enqueue or whether I am opting for Dequeue or whether I am opting for the displaying the content of the queue. So as it is a menu driven program, if you see, there are a few printf statement, 1 for Enqueue, 2 for Dequeue, 3 for display, and 4 to exit. After that I am reading the choice. Now if my choice is 1, I am reading the element to be inserted onto the queue. After reading the element, if you see, I am calling the Enqueue function with 2 arguments. If you remember, the Enqueue function was written with 2 arguments: the reference of the queue and the item to be pushed on, the item to be inserted onto the queue. And then the Enqueue function was returning the address. Hence, the Enqueue function is being the return value is stored in the variable start. Similarly, the Dequeue function was written with 1 argument, that is the reference of my queue, and the return value is stored in start, which holds the address of my first node in the queue. Now, case 3 is for display. Even display is written with 1 argument, and if you remember, display function was return type was void, so I am not holding the return value of display. Default exit 0, and then this is for close is for my switch statement, this is for my for loop, and having return 0, and then I am closing my main function. Hope this is clear. This is about how to implement a queue of integers using a single linked list. Thank you.